All right, so good afternoon. Thanks a lot for coming to our talk. I know we have kind of the unfortunate role now to be the last barrier between the party and you, so we'd hopefully make that time for you as pleasant as possible. So sit back and relax, enjoy the show. There will be drinks afterwards. And we'll start pretty quickly with an introduction of ourselves. We've already been announced. Well, we didn't put the term dynamic duo in there. We might update the slides in the future. Yeah, so I'm Matthias, as said, working for a company called Novatech. We are actually sponsor here at this conference, so that we have a booth in the main area. Would like you to invite you to come over and have a chat with me or my colleagues. We also have, I'm going to switch right back. Okay. a raffle there where you can win some iPods, not iPods, AirPods, and yeah, so that's me. And now hand over to Tiffany, please.
Oh, thank you so much. Yeah, so obviously I'm Tiffany. I think it's basically been said, developer advocate at VMware. Who here has heard of the term developer advocate? Half the room, okay. But it involves stuff like this. And then if you use Twitter/X or whatever, our handles are at the bottom there. I feel like fewer and fewer people use it, but it's still a thing, I guess.
All right, good. So with that, we can start. Before we go into the topic, maybe a few words how we came to that idea to do this talk and to do this talk together. As you've seen, Tiffany works for a company, VMware, that basically provides a managed solution for Kubernetes in the Tanzu suite. Novatech basically comes from a bit of a different angle. We are more coming from a software development side. We help people adopting the cloud-native journey, onboard them skill-wise and technique-wise on this technology. And of course, we've seen many different scenarios of running workloads in production. And so we try to summarize and combine our ideas and things we've discovered in this talk. All right, so mostly we try to do fancy sketches. I mean, in the end, what is this going to be about? Of course, cloud services, providing services to the end user. In the end, we want to make the end user happy with the services that are being provided. And we're going to have a look what we have to do on the side of the system then, basically to make this all happen. Now, the title says how to make production rhyme with production readiness. No. How to make Kubernetes rhyme with production readiness. So there is no official term for production readiness. So we just try to put something together here that what we think of it, to say basically this is the state of a system which is fully prepared and capable of running productive workloads. Or to seen from the side of the users, it basically provides the level of service and performance that the user requires to make them happy with the service. All right. Normally, we try to do sketches and more entertaining slides. We try to reduce bulleted lists to a minimum. I think this is the only one in that slide deck. There are a few more details, what production readiness and what ties into that. Of course, you will find here most functional and non-functional requirements to make your system capable of being production ready. Of course, this basically goes outside of the scope of Kubernetes, but as this is ContainerDays here, we're going to narrow it down to the scope of Kubernetes, and you will find things here like it has to be tested well, stable, reliable, secure, performing well, probably documented, observable, and easy to upgrade, and a couple of things more. And then with this talk, we're going to look at what would a vanilla Kubernetes provide out of the box on those things, and then later on compare it, what would basically be your task as an administrator to bring Kubernetes into that state of fulfilling all of these. So with this...
All right, so I mean, he basically said what's on the slide, but
Sorry.
So production readiness, basically, of course, is a thing that is not just specific to Kubernetes. It's a thing in general, but as this is ContainerDays, it kind of makes sense. Who here has used Kubernetes before? Most everyone. OK, cool. All right. Okay, so for the folks that don't know, basically at a very high level, Kubernetes basically runs and manages your container workloads. So you could have, hey, I have this application and I want to run a bunch of copies of it. I want to have high availability. Like, how do I handle this? So that's where Kubernetes basically comes along. If you look at this lovely diagram that Matthias made, you can see a bunch of users and they are interacting, like creating a bunch of different pods. And so there's things like built-in logging. You can use kubectl logs. There's things if you have access to the control plane, you can SSH in and look at kubelet logs, for instance, as well. So as like a little like high-level thing, Kubernetes basically is a distributed platform for running, connecting, and logging your containerized workloads. So it's pretty flexible on the infrastructure level. So independent of whatever you are running on it, you can go and scale up. You can be starting your cluster with, I just want to have one node. I don't want to pay a bunch of money, and I just want to run a few things. But then later, maybe you need more CPU and memory, maybe so you need more nodes, and you can easily be able to scale up, especially if you're using some sort of managed offering. And with that as well, you can also easily scale down without disrupting the behavior of your applications. So not just for infrastructure as well, you can also scale and be highly available on the workload level too. So for instance, you can be like, hey, I only have 3 copies of my application running. I now want it to be 50 for some reason. You can do that. You can deploy new versions, and you can do graceful migration with that as well. And then there's also things like fault tolerance that we're going to talk about later too. But basically, these are things that you can expect with just having vanilla Kubernetes. So this is just like a little like basic like 101 of like some of the Kubernetes like workload behavior and some of the possibilities. So you can do things as I just mentioned, like with scaling. There's load balancing, so it will automatically load balance between the multiple copies that you have of a pod with your service. There is auto restarting, so if you aren't just creating a pod, so if you create a deployment, if your pod dies, it will create a new one, so fault tolerance. And then also being able to have updates without downtime as well. So just now in a slightly bulleted list, but in graphic form. Yeah, so just to recap on that stuff, so there's high availability and resilience of your workloads. There's fault tolerance. There's elasticity for both the infrastructure and your workloads as well, and also extensibility.
All right, so yeah, as a lot of people raised their hands before, and you probably have heard most of those things before, especially if you've been working with it for a while. But this is an introductory talk, so we just want to make sure that everybody has kind of the same understanding of what we're talking about here. And as you could see, like this core of Kubernetes is very much focused on stability of your applications, like scaling up and restarting them and all that things. And this core will always be the same, no matter and work in the same way, no matter if you're on a Raspberry Pi or as on a cloud service or and whatever else. Now, this of course leaves the question: what is then missing? I mean, what are the pieces that still should be added and configured to make the overall thing complete and be able to provide production-ready services? We've discovered, of course, quite a few things over time, and they're also, of course, not always the same for every kind of situation. So what we try to do is kind of categorize and group them a little bit into different boxes, so to say. So definitely you have to look a thing on the infrastructure side, because as I just said, you can run Kubernetes in different environments, and then it means you, of course, need to be provide the infrastructure components. On top of that, there is the network. Of course, Kubernetes provides, as we've seen, network connectivity, so you can connect the services that they talk with each other. But there's still advanced configurations that you might want to have, and we're going to have a look on how to configure them. Then there's security and observability. So of course, you want your system to be secure. Of course, you also want to see what's going on. These are all things which Kubernetes provides some things for, but not like covering it to the extent where we think is actually necessary. And then on top, there are workloads. So this is like arguably a part or not a part of Kubernetes, but still, of course, you as a deployer, you want to run your things on the platform. whatever makes it this easier for you helps you, of course, to roll out things easier and quicker. So, yeah. On the infrastructure side of things, I mean, this is basically goes without saying. You need to provide the VMs, the network, the storage, and so on, and also the connection to managed services. Now, Kubernetes provides some things in there. So let's say, maybe this is on the next slide. No, I meant this one. Sorry, I'm kind of distracted always looking down here. So Kubernetes has objects when it comes to like storage and accessing attached storage, like persistent volumes and persistent volume claims. So the API objects, in order to deal with them from a Kubernetes perspective, are there, but that doesn't mean the actual hardware is present. And this is something you need to configure and set up also for things like backups of your infrastructure. These are all things you have to worry about when doing this by yourself. Then also on the network side, there are different aspects. Like if you look at the traffic that goes into your cluster from outside and also like leaving the cluster again, you need to configure things like an Ingress controller, and that's like where the thing begins. You need that various options, and you need to deal with all that, and it's just time consuming and an effort that you need to consider. There's the gateway API, and of course you can add own custom implementations to handle that as well. From the outside traffic, we can also look on the inside. So as I said before, like Kubernetes has the service object, and then that makes your pods accessible, so components can talk with each other. But if you want to have some advanced things, like for example, a secure connection or an encrypted connection between two components, or more kind of granular network control to say I roll out a new version in a canary style deployment, and I only want to do this start with 20% and increase it over time. These are things you won't be able to do with plain Kubernetes. You won't need to add things like service meshes in order to get onto this level. And yeah, so network policies, encryption, and advanced routing, I already mentioned that. Observability, we've just it was a great talk here by Dotan in the slot just before us. I hope you saw it, or I hope you got a place in there. It was pretty packed. Yeah, observability provides pretty much a big own landscape on things that you might want to use. I mean, and this starts from monitoring your infrastructure itself, then monitoring the API objects, and then even go into like the network connections or the application metrics. And for each of those different ones, you need to figure out which is the solution that you want to use. So there's a tool stack that you have to decide on in order to get all this information out.
And if you want to hear us talk probably too much about observability, we're going to be talking about that at KubeCon Shanghai and DevOps Belgium.
So if you're around in Shanghai in 2 weeks, maybe it would be nice to see you all again. And if you're not, the talk will probably be recorded. Yeah, we're also looking forward to that. Now, security is one of the boxes we also mentioned before. Of course, Kubernetes, like with all the other things, Kubernetes provides API objects and concepts to do so, but in the end, it's still about you that you have to set up the policy and define it in a way which makes best sense for your application. So by default, there's not much insecurity enabled when you have like a naked cluster. It's your responsibility to set up service accounts, RBAC rules, so basically say those user group is available to access this workspace, or who has kubectl access and who has not. For example, in most of our situations, we actually do not give any kubectl access to end users on production clusters, so only the CI/CD pipelines would get that. And yeah, so there's definitely a lot more. And the final thing is, as I said before, the workloads. So you could potentially argue this is basically in the responsibility of the developers or people who provide the workloads, but still, there are things that might it make easier for you to simplify your application deployment or your updates and all those things. So also maybe you want to also have already some built-in monitoring by the time you deploy the applications. All of that is something you need to take under consideration. This is, for example, a typical workflow as we see it very often in our environments, like coming from a Git repo where the code is, going over build, test, containerize until you deploy. And of course, those things also need to be secure. GitSecOps is kind of a term here where you can apply and use tooling to put all this into an overall picture. All right. So this summary kind of slide is intentionally chaotic because we just try to put all the things that I've just talked about in that picture, but this is more like the reality. This is probably what you're going to face when you want to build a complete solution where all of these aspects are being covered. And our thing is just really to say, don't underestimate this because there will be quite a few things to do. All right. I think with that, you want to take over from here?
Sure, I guess I can do that. But yeah, just the other slides, just like recapping with the different categories that we broke it down into. So this is a little checklist that we put together of some of the things that you could consider caring about. It's not necessarily that you need every single one of these things. Maybe there's certain things you need. Maybe there's things that aren't on that list. So for instance, there's a bunch of stuff with like logging. There's things with metrics server. Maybe you want to have service mesh or network policies or some sort of backups of some sort. So this is just kind of like to put everything in like a single little area. Who here has seen the CNCF landscape before? Okay, yeah. As you probably remember, it's a little chaotic. I mean, it's kind of cool that it's so big, but then it's also like, okay, well, here is like, there's security, here's observability, there's just so many different things there, and trying to figure out one, like, where do I even start? Or if anyone happens to know every single thing on here, like, I want your memory, that's not fair. But basically, what I'm going to go into next is like some of the projects that maybe are like CNCF, graduated incubating sandbox, or some of the specific projects that Matthias and I have interacted with. It doesn't mean that those are the only right options. It's just I would prefer not talking about things that I know nothing about. So for the infrastructure level things, so there's things like cluster APIs. So you have CRDs to create Kubernetes like cluster resources. There's Valero for backing up your workloads on your cluster and also for persistent volumes. So those two specifically are for Kubernetes. And then we also have things like Terraform, Pulumi, and Crossplane, which are like infrastructure as code. And you can then use those to, for instance, create Kubernetes infrastructure. You can use it to create a bunch of other things outside of Kubernetes as well. So then we have networking. So for like Istio and Linkerd, so like mentioned a little bit earlier, so there's service mesh. Actually, so who here has heard of service mesh? Okay. Captherm. All right. So basically, Matthias kind of mentioned a little bit earlier, but like it's more than just like networking too. It has things with like security, observability. You can do things like specific like routing that you want to do. There is also Cilium, which is similar-ish in that kind of vein. So like it uses a low-level Linux kernel network technology. Who here has heard of eBPF? Actually, about the same. Okay. Why are you laughing at me?
No, I was just like, they know this already. So it's like.
So like analogy that's been made is that like eBPF is for the Linux kernel, like what JavaScript is for our website. So basically, instead of what you may commonly know for service mesh, where you end up having a sidecar that's running in every single one of your pods, instead for this, it interacts with the network on a node level, and it can do things like service mesh, observability, etc. There's also Entreo, which implements CNI, which is the container network interface, and Kubernetes network policy, and then that provides network connectivity and security for your pod workloads.
Just one thing, as you've just mentioned, Cilium and eBPF, if you want to know more about that, there was just a very excellent talk by our friends from White Duck, Nico and Philip, in the session before that. So in case you want to know more about technology and you missed that talk, I certainly recommend to watch that one on YouTube. All right.
Okay, so observability. So a lot of folks may have used Prometheus. You can go and get a bunch of metrics from either like cluster level, or maybe you decide you want specific metrics from your application. But generally speaking, if you just have a bunch of numbers, that might be hard to figure out what to do with it. Maybe you actually want to see, are are the numbers around what you want it to be? Is it changing how you expect it to, et cetera? So that's where Grafana ends up coming in. It's a dashboard that you can use to visualize things. There's also stuff like Alert Manager, where you can set alerts if some threshold is hit. There's Jaeger, which is for distributed tracing. There's OpenTelemetry, which is like a standard observability integration layer for like logs, metrics, and traces. There's Kiali, which is observability specifically for service meshes. And then there's like FluentD for logging. And then for security, so there's things like OPA and Kyverno, which are policy-based control. There's Cert Manager, which, I mean, it might be self-explanatory. It's used for managing certificates. There's much more. I'm going to skip through some of the things here, but like, so there's things like Intoto, which is for supply chain integrity. In the last couple of years, a lot of people have been talking about supply chain security. There's things like Spiffy and Spire, which is for identity, and there's several other things as well. And then now this is where we get to like workloads, so what's actually running on your cluster. So there's things like Flux and Argo for continuous delivery, so that's like part of your CI/CD pipeline. If you think back to the slide that had like the Git sec ops and all the things with that. Who here is a little annoyed with how much YAML you have to deal with Kubernetes? Less people than I thought. Okay, are you actually using Kubernetes? So basically, instead of having a bunch of YAML files and maybe copy pasting a bunch of stuff, there are tools out there that can help. There's things with Helm for packaging. There's part of the Carvel tool suite that has like YTT, but basically you can be like, hey, I have this template thing and I want values from some other file, etc. There's things like Cap, which also helps you run your applications. There's Cap Controller, where like say you could have it where I changed code on GitHub and it will rerun things based on what you have there. Then there's also things like Harbor for container registry, because with Kubernetes, if you don't have your image in a registry, you don't have any applications running. All right, so now what?
I would just like step in here real quick. Now, I mean, this part was pretty difficult for us to like narrow down to a couple of technologies, and some of you might probably wondering why is this and that one not listed. Always, please feel free to give us feedback on certain technologies that we might have been missing out, because as you see, in this landscape is big. We also don't know all of those technologies, and by having something not on this slide doesn't really mean we would not like recommend it. It might just be that we also still don't know it, and the landscape is in a very steady change, and it's also difficult for us to stay on track there. In the end, it's just like we try to focus on the graduated and incubating one, and the ones we basically have some experience with. All right.
Okay, so it feels like everything like before the pandemic started is really old, so this is kind of really old. But it's from Kelsey Hightower, and basically he's saying that it's your responsibility to purchase, staff, patch, scale, and upgrade if you are dealing with like running your entire own Kubernetes and not letting someone do that for you. You have to keep all of these things in sync, which can be a lot. So we broke it down into 3 separate things. We have it with unmanaged, managed, and what we're calling fully managed. There's a little star because it's just what we named it. This isn't some official terminology of some sorts. So, like, and then there's the ... because there's things in between these options as well. There isn't really a thing that like this one is right, one is wrong. It just kind of depends on what you specifically need, and like how do you want to spend this like time and money that you have like on people for whether it's just focusing on applications, whether it's working on infrastructure, all that stuff. So basically everything that's in red is stuff that you are managing. So if you have unmanaged, you are managing all of that yourself. If you have it for managed, then a provider of some sort that you're using will be managing your infrastructure, like the hardware and Kubernetes itself, and then you have to still deal with the security, the network observability, and your applications/workloads. Then what we're calling fully managed is just adding that extra layer there that you don't have to deal with everything with yourself for basically some of the topics that we were already talking about in previous slides with security, networking, and observability. So basically, it's just like depending on like how much responsibility versus how much control that you want with what you're trying to manage. So this is an example for Tanzu Kubernetes Grid. And you might recognize a bunch of the different tools that are over there. I think most everything, except for I don't think Calico showed up earlier. Actually, 2 of the founders of Tigera, which created Calico, are at this conference and are speaking right now. So thanks for coming here instead. But yeah, so basically this is just like one idea of like how people have decided that they wanted to bundle tools to be able to fill in the gaps of what they needed from what is there for vanilla Kubernetes. This, again, isn't the like only way of doing it. It's just one of them.
Yeah, I mean, so if we put this into perspective here again, so this of course would then be an example of like a fully managed, because like in this case, VMware comes in as a provider and says, okay, we're gonna spend our time on making sure we're gonna put components together to fulfill all that and to make them work, so you don't have to do it. Of course, I mean, you can do it on your own, but then you will probably pay in time what you don't pay in a service in another form. So this is, for example, let's say, an overview of a training environment we provide. So we teach Kubernetes classes quite a lot, and we try to do that on a vanilla Kubernetes version to not do any kind of vendor pitch there. And what we basically do is we assemble all of those add-ons in our own way, and we I mean, as it's just a training environment, it's not something where you could say this is something which is like super production ready, but still we're gonna gain a lot of experience from that, what it actually means to keep all those things in sync, because Kubernetes updates frequently, and that also makes the things on top sometimes not working anymore in the same way, and they have their own update cycles. So this is just something what we learned is that you shouldn't underestimate if you want to build and maintain all those things by yourself. All right.
Yeah, like I've definitely even just had running on my laptop, I updated some version of some tool, and then suddenly another tool is not in sync with it, it's broken, and I have to deal with that. And even just that is really annoying. So this is like a little rough decision metric for choosing between running in the cloud versus running on-prem. And this isn't necessarily all of the options that lead you somewhere. This is just potential ones. So like say if you have a ton of bare metal lying around, and I mean like a ton, unless you just have like buckets of money, and if you do, please share. In that case, you probably want to do on-prem. If you have things that are like sensitive apps, so for instance, if it's like military, intelligence, medical, etc., then the next question is, does your country have some sort of cloud that is approved for you being able to do this? If no, then you would want to do on-prem, and otherwise, then you probably would want to go with the cloud. And in most scenarios, you probably want to end up going with using the cloud instead. And then the other question is, do I want to have managed or do I want to have self-hosted? So basically, like, do you want to run it yourself or do you want to have someone else run it for you? So generally speaking, you probably want it to be managed, except for in some circumstances for like maybe if it's on-prem that you might not want to, or maybe you have some huge cluster where you have thousands of nodes or something, and the cloud provider doesn't support that number of them. Or maybe you need some like shiny new thing that's in Kubernetes, because most of the time the managed offerings are slightly behind the latest version of Kubernetes, or maybe you need to make it so some beta thing is something that you can use. And then I throw a catch-all in there of like, maybe you tried it managed and it just didn't work for you. So then I guess in that case you would also want to do self-hosted. So our friend Jerome Pedizzoni made this quote even earlier than the other one from Kelsey, that the fastest, easiest, and cheapest way to run your Kubernetes cluster is to get someone else to do it for you. He also is the creator of the title of this talk and some of the ideas behind it in general. But basically, yeah, it's best, if you can, to just not worry about it and have someone else run it for you and actually just worry about running your applications and not so many other things. Let someone else who's been spending all their time working on this do it for you.
All right. So yeah, this I have now the pleasure to do the other bulleted list again in our talk, and this is already the last one. So I mean, to wrap things up here, I mean, normally the content of this talk is what people don't really want to hear, because instead of like showing new and shiny features, we really talk more about what you actually need to take care of in order to get things working well. But still is something you have to deal with and to consider. And the recommendation, as I said before, is don't underestimate that. In the end, of course, there is no like one golden path or right or wrong, which would work out for every client scenario. So of course we could give a bit of an idea. So try to set up some kind of checklist. What is important for you? What does your landscape need? And then try to see what kind of technologies can help you with that. The other thing you need to be aware of is, like, if you don't buy things as a service, you basically pay the same price for investing the skill in your own people. And this is like the question that you need to make. Do I want my own team to run the things, or do I want my own people rather to focus on application development and business logic rather than working on that stack? I mean, in the end, we would always recommend to use the highest abstraction possible. You saw the quotes from Kelsey and from Jerome. Also, it was mentioned before that I'm an ambassador for Cloud Foundry, so there's also a PaaS solution where, with the idea to say, yeah, don't try to solve problems that somebody else has already solved. I mean, the differentiator will be your application and your business logic, and not maintaining the stack underneath. Sometimes this might not be possible in that way, and sometimes people might want to do it in a different way. But then this is what you probably should go through and see which combination do you want to apply. Yeah, so this is pretty much all of that. And yeah, finally, like if you have that decision in front of you, I of course need to say, try to use some managed solution like as VMware offers. If you decide to like build up your own skills and your own team, then please feel free to see us. We can give consultancy and enablement on that. And with that, I think we have 3 or 4 minutes remaining, so we can do a couple of questions. And if not, we're gonna let you out to the drinks a little bit earlier. So with that, first of all, I wanted to say thanks a lot for coming and listening.
Big congratulations. I definitely share the sentiment of some of these Slido questions, and I think it was a great presentation, and you don't often see production readiness linked so clearly to CNCF technologies. So yeah, it was a great session. So there's one question here. As part of monitoring critical performance-intensive applications deployed in Kubernetes, what are mandatory targets that should be monitored?
Yeah, this is, as we said, pretty much for this particular question, we have another full-length talk. And so it's kind of difficult to answer it in 1 or 2 sentences. I mean, this is... monitoring in Kubernetes has various levels and various, like, let's say, altitudes. How much are you going to put into the environment, and how much do you really need to take out of it? And as I said, this can start from a basic vanilla Kubernetes where you can do logs and trap things from the metric server and so on. Then goes a level higher, using something like service mesh when you can get all the metrics like in between the components. And then finally, like, on the application side of things, where things like OpenTelemetry would give you information of what is your application doing and performing. What are mandatory things is probably not something that we can decide for you, because you know what the mandatory outcomes have to be in your own environment. The good thing with this CNCF technology is like most of them, of course, are open source, and you can just like apply them, try them out, and see what works for you and what doesn't. This is probably something I would recommend before I start buying expensive, like full coverage observability solutions, because then you might pay for something which you're actually not going to need. This was also like, I think, something that in Dotan's talk before that said like a lot of the actual monitored metrics are never being queried or analyzed. So yeah, basically do an iterative approach and see what helps you. You can always go deeper, but I wouldn't start with the most complex thing, because it will definitely affect your overall performance, and that's probably not what you want to do.
Thanks for the comprehensive answer.
Yeah, I can't make that short.
The last one is more a compliment than a question, but people want to see your slides, so definitely share them on social media.
So we did this talk for the first time at KubeCon. So if you go to speakerdeck.com/Tiffany Fay, if there might be a J, I'm pretty sure there's not. I think it's just Tiffany Fay. There would be slides from that for this.
we'll just put it on Twitter right now, and then
that too.
I mean, yeah, we have a couple of updated slides for this ContainerDays version because some of the products or projects have actually changed in their graduation status and some things like that. But the essential thing is the same. And yeah, thanks for the compliment that you like the slides.
That's all the questions we have on Slido. But is there any burning question in the audience right now? All right, well, you can find Tiffany and Matthias at the party later. Give them one more round of applause, please. They're our closing speakers.